On number 12,
Yes,
on
ma'am.
sequence 4, I had number 9.
I'm confused what you're saying was number 9.
On 4, instead of 3, I had 9 first.
On 4.
14.
No, I just told him 12.
I know. Here you had a 9?
Mm-hmm,
Why'd you get a 9 here?
because I was doing it in my head.
But were you subtracting 1 every time?
I did start using, I used subtract, I used everything.
But
I was trying to do it in my head, to see what it equal to.
why would you do things in your head? Have I ever rewarded y'all for doing the math in your head?
No.
Because doing stuff in your head doesn't matter. What matters is your ability to think. I don't care if you do it in your head. I'd rather you actually write it out so I can see your logic. But Mona, I need you to notice we end at -6. If I subtract 1, subtract 1, subtract 1, subtract 1, subtract 1, and subtract 1, do I get down to -6? Nowhere close. Now, this is a skill that a whole lot of us struggled with last semester, or the beginning of this semester, and I need you to hear me very clearly on this. Tonight's homework is going to be for an accuracy check, and it's going to be on these exact skills. So I need you to pay attention and ask what questions you need. Now, Alan, you came in yesterday, and I was super happy to have you here for tutoring. What was your original strategy for tackling something like number 12? Do you remember?
I remember explaining it to you.
Yeah, I felt like I remember you saying that you tried subtracting 2 and it didn't
Yeah,
work.
subtracting 2 and 4 and 5 as well, and then finally came back down to 3 and 2, and 3 got me to where I was.
Which, we talked about over here, what strategy were you using?
The one with the star on guess, check, and improve the solution.
You can always guess, check, and improve a solution. I'm always okay with that. But that took a lot of work to subtract
Yes,
2 all the way through, and subtract 4 all the way through, and subtract 5 all the way through, right? As long as you understand the nature of this sequence, you should be pretty good to find these arithmetic means. If it is arithmetic, what are you repeatedly doing? You're repeatedly adding, right? This was arithmetic. So we saw repeated addition, which, remember, you can also add a negative. So that is a possibility as well. But a fundamental truth comes into play here, and this is important. How do we mathematically, or what operation mathematically shows repeated addition? Multiplication, right? You can use that to your advantage here. Because if you work through, you do know the common difference is -3, but before you've worked through this problem, do you know what your additive rate of change is?
No.
No? So Gavin, what can we use for something that we don't know in mathematics?
A letter.
Which is a variable, right? We can use a letter to represent an unknown, a variable, right? So you see how I used plus D here? Plus D, plus D, plus D, plus D, plus D, right? We're adding that common difference all the way through. Where did I start, though?
At 12.
I started at 12. And what am I doing to that 12, Jeffrey? Say again? Say it louder. Well, maybe eventually, but do I have subtraction yet? We will eventually get there, but right now, before I've worked this problem out, do I know what I'm adding by? So I'm adding a D. Hey Zay, how well are you going to take notes if your pencils are stacked up like that? So, Linnea, how many times did I add D here?
6.
I added D 6 times. So Caroline,
No.
how could I show the fact that I'm repeatedly adding that common difference 6 times? Any ideas? You have a pencil in your hand to take notes?
I already took everything.
I mean, the notes that we're doing right now is we're learning because there are things we didn't know. Also, please keep your mask up. Say you as well. Thank you, sir. Gavin.
16.
Say again.
Nothing.
Mona, what do you think about Gavin's idea of plus 6D?
Yes. I found that trigger.
Yeah, that's right, because 12 is the ratio. 6 is the common difference.
If you need a minus one,
We're not done yet.
oh,
We'll look at that in a second. But Mona, you say that 12 is the ratio. I feel like is
My bad,
that a
my bad,
ratio right there?
My bad, no. My bad, my bad.
What is that 12?
starting,
That's where we started,
My
right?
bad,
You good with that idea?
yeah.
Now, you also, Mona, said that 6 is the common difference. So why do I still have a D here if you think that D is 6? Remember, saying that D is 6 is the same thing as this. That they are equal to each other. Is that common difference 6?
I thought it was negative 6.
Okay. If I subtract 6, what's 12 minus 6? 6. What's 6 minus 6? 0 minus 6. I've already gotten to negative 6. I'm supposed to end there, right? Mona, how many times am I adding that common difference? So it's not that the common difference is 6. I'm adding the common difference 6 times. And how do we show repeated addition?
Somebody's phone ring.
It's times the common difference. Yo.
You hear?
which one is it? Well, we'll never know.
Why are we missing 3 phones?
Check
Anthony
my-
doesn't
check
have
my
his.
account.
Who else doesn't have a phone?
16.
Light is in my pocket, I forgot about it.
Y'all killing me.
Oh, I got here
Who
late.
called?
That's
Who
true.
called?
Nuh-uh. We're not looking to see who called in the middle of class, eh?
Wait,
The whole point of the phone being up there is so that you are not distracted by it.
my fault.
I like being distracted.
What name is it?
I know y'all like being distracted. That's 90% of the issue.
I didn't get distracted by it, I forgot I had it on it.
I know.
ADD, yeah.
I'm sure.
Donovan, where's yours? I wonder what number? Donovan, you're number 8, dude. Start putting in number 8. Thank you, sir. Jeffrey, you don't have one, do you? Okay. All right. Are we all good with the expression 12 plus 6 times d then? This is fundamental to what we're about to do, which is something we've struggled with in the past. So Zay, after we start at 12 and we add our common difference 6 times, what do we end at? So what could I say between 12 plus 6d and negative 6? They are what? Anyone know?
Reciprocal. Identical. Equal. It's one of those, come on.
I mean, if I start at 12 and I add my common difference 6 times, do I get down to negative 6?
Yes.
Yeah,
So these two things would be
equal.
equal. How could I use this? Oh, and McKay, earlier you asked, do we need to do a d minus 1, right? So if you had done 7 minus 1, you would get the 6. That's where the minus 1 would come from. Notice literally how many times are you adding the common difference?
6.
6 times, so you don't have to do that there. Okay? Alright, so once you write this equation, we should be able to find that common difference pretty easily. What could I do at this point to find my common difference? Donovan? Where are you doing minus 6 from?
Minus 6. Oh, no. I don't know.
Zay, any ideas? Hmm?
Don't you gotta get the variable by itself?
I do want this variable to be on its own so that I know what d is equal to.
But you gotta do minus 12.
So if I do 12 minus 12, what do I get?
Or 0.
I get a 0 there. Okay, so that's eliminating something that's there.
And you gotta do it on the negative 6.
I gotta do it on the negative 6 as well? Why is that?
Or whatever
We
do
do
on
gotta
one
do
side,
both sides.
Okay, so we've heard this idea of whatever we do to one side, we have to do to the other side. Does anyone know why that's true?
Because it's
Because Ms. Hydrick told us, what? So-
It's equal, I don't know.
It is actually a good bit associated with that. Hold on to that question of why do we have to do that, because I promise you, next unit, that will come up very heavily.
So I can, no, okay, I'm checking.
You're not wrong. It's a little bit more than just that. We'll talk about it then.
Don't you
Okay,
know if I
so
remember
what is
that?
0 plus 60?
Read that song.
0 plus 60 is 60.
It's at the
That's-
bottom.
A good point. All right, so negative 18. Now what would I do?
Divide by
It's
6.
fine.
Divide by 6.
Don't
Donovan, why did you know to divide?
Because the time you multiply are equal.
Hey, y'all, are you paying attention to this conversation Donovan's having and things he's explaining?
Yeah, I know.
What did he say?
Reciprocity.
He never said anything about a reciprocal. A reciprocal would work here, but that's not what he said. Donovan, what did you say?
Divide by 6.
Why did you say divide by 6?
Because you multiply 6 times 6.
Do you think I'm deaf? Stop talking and listen. Be respectful to your classmates.
These cards were killed.
Hey, that language is unnecessary. We do not use the Lord's name in vain in my class. I'm not asking you to believe the same things I do, but I am asking you to not use the Lord's name in vain. Alright,
I respect.
so 6 times d is what you're saying. We're multiplying, so the inverse of multiplication is
Division.
division, right? Another and more important thing is this. What is 6 divided by 6?
1.
And so I'm left with 1 times d, or just d, equals negative 3.
Just do.
So if I repeatedly subtract 3 or add a negative 3, do I get down to that negative 6?
Yes.
Yeah, that strategy, notice it took us a while to get there because we weren't all paying attention or all engaged in the conversation, but that is a very efficient strategy to find that common difference. That can also work on number 14. Guessing and checking will take more time, especially when it comes to a geometric mean, because if it is geometric, what do we know is happening, Mona?
It's being multiplied.
Okay, we're repeatedly multiplying. What do we call that multiplicative rate of change? Gavin?
Oh. Exponential.
That's what we call the multiplicative rate of change?
No, it's not.
Nope. An exponential function is what a geometric sequence is a type of, but that is not
I didn't know that.
the rate of change. Well, we better start looking at our graphic organizers and writing stuff down.
Or
It's R, a common
ratio.
ratio, thank you. But notice how we're multiplying by the common ratio. Instead of starting at 12, where are we starting for number 14? 7. So what are we going to do to that 7? Linnea, what are we doing to our 7?
Multiply.
By?
Or. JK, sorry.
I mean, are we multiplying by R?
Yes.
Multiplying by the common ratio? So what's next?
It's always the third because there's 3 terms to get to number 4.
Okay, and it's not just there's 3 terms. What are we doing with those 3 terms? We're repeatedly,
Multiplying
how do we mathematically, what's a mathematical operation that shows repeated multiplication?
Then you press the
it.
carry.
X.
Yeah.
An exponent. After I multiply by r cubed, what do I get?
7R cubed. So equals 875.
There we go. Now I need to find the common ratio. How am I going to do it? Hey
7.
Mona, what do you type into your calculator?
Figure out why I went wrong.
Okay, but we're having a whole class discussion about this. If you have a question about where you went wrong, ask it from the class and I can help answer it. I also need you to pay attention to this because we then get confused later and we're like, I have no clue how to do this. Well, did you pay attention when I went over it in class? We're going over how to approach this problem right now. If you have a question, cool, I'm more than happy to answer it. But if you're stuck and you're confused, how about you ask? And I'll be more than happy to help you. If you do that, sitting on your calculator, you're going to be making mistakes later because you're not hearing what we're talking about now. Okay? So what can I do at this point to find the common ratio?
Divide 7 by 7.
Okay, not just 7, but divide
And
the whole expression
whole
by 7.
expression, and then 875 by 7 as well.
Okay, what is 7 divided by 7?
1.
So r cubed equals, now you have to plug it in the calculator, but 125. Does anyone remember what the inverse of a cube is? Say that again, Donovan? A cube root.
Oh.
So r would equal 5. Multiply by 5, you get up to 875. Now, this also brings us up to a detail that we talked about last semester, actually, I guess is when we ended on this. Nope, 125. One thing I want to remind you of, because we talked about it last semester, and it's going to come back up in just a minute. Can't I raise this to the 1/3 power? When you raise a power to a power, what do you do with those powers? You multiply them. What is 3 times 1/3? That's a 1. You don't need a calculator. What is 3 divided by 3?
Just
1, so that's r to the first. Does raising it to the 1/3 also get me to r to the first?
Yes.
Which means that if I have the cube root of a and a to the 1/3, they're what to each other?
Equal?
Close,
Equivalent.
equivalent,
Equivalent.
right? Equal does not mean that they're always the same. Equivalent means that they may look different, but they're effectively the same. These things are equivalent. A cube root is the same thing as raising something to the 1/3 power. Hopefully that jogs a few memories from last semester. If not, we will pick back up with it tomorrow. But also, this is a little bit easier to plug into a calculator. That's the reason I'm bringing it up. So r is equal to 5. But notice it's based off of understanding what a common difference and what a common ratio are. I'm repeatedly adding, I'm repeatedly multiplying. Sound good? Questions? Let's rock and roll. So, let's look at 16. Fill in the tables of values and find the factor used to move between the whole numbers. Notice how they say a factor. What do we do with factors? You multiply them. So what am I multiplying 4 by to get over here to 16? So what do we need to multiply by to get all the way over here to 64?
4.
But then, how am I getting this 8?
It's split, so it's therefore you're multiplying by 2 instead.
Times.
See, that's what we want to recognize. Notice, I'm not going to switch from multiplication to addition, am I?
No.
But if I multiply by 2, multiply by 2, and multiply by 2, and multiply by 2, does that work all the way through?
Yes, it does.
It does. Notice, another way to understand this is, if I didn't know what this term was,
It has the thing on this one. I apologize.
you're good. Can't I use this idea that I'm repeatedly multiplying by f sub c squared? Or I'm multiplying by it twice.
Yes.
Your homework will be for accuracy tonight. Be aware of that.
So we
I would hope that you took some notes.
I got it, guys.
Any questions before we move on today?
Hold on.
What else about that?
Hold on.
For
How did you
D
get that?
and E, I didn't understand, like, when I first read it, like, because it had switched the letters. I realize it now with it being up there, but it switched them around. I was like,
Yeah, you just have to pay attention to.
I didn't
Notice
know
they
if
define it up here.
Yeah.
F sub W is the whole number values, right? The
So-
factor to move between the whole number values. F sub C is to move between each column, right? Because notice how it's half steps up there?
Yeah, it's just they had switched around. I didn't know if it was a typo error or if they don't know.
Gotcha.
That's not.
Mona, what's your question?
How did you get that? 'Cause the way I did it, it's totally different.
Did you get the right answer? Okay, what did you do?
Okay, so I added 6 each time.
So that's the beginning of the issue. What do you do with factors?
Multiply them.
You multiply factors.
Mhm.
So understanding that it's a factor, you have to recognize, okay, I need to multiply. Notice how I multiplied by 4. 4 times 4 is 16. 16 times 4 is 64. Right? And so I also pointed out, if you don't know what this f sub c is, similar to what we did with number 14, we multiplied by f sub c twice, and then we got to 16. Alright? And so I just solved this equation. Okay? That's what I was doing here, is I just solved that equation. Does that explain things?
Hold on.
Is that what was causing you trouble? You just didn't realize that word factor?
Yeah, I didn't realize I thought I had to add each time to figure out what I needed to add.
Yeah, you gotta pay attention to those details. We multiply with factors. We do not add them.
Hold on, go back.
It's still up here.
No, that, yeah, because I wrote what you had on the board first.
They're getting what's already was previously wrote up there, or rewrote down.
One thing ahead of me.
When it explains what these numbers mean.
I know, it's lovely to have you too, Caroline.
Okay.
No need to be rude.
Mr. Kenny, for explaining what these numbers mean, is it pretty much just the times 2 and the times 4? Alright.
Okay, so we're gonna look at the objectives for the graphic organizer, and we're gonna wrap that up today. If we don't wrap it up today, it's gonna be your job to finish filling it out on your own. So, we want to be able to use the units 1 and 2 graphic organizer to explain how key concepts are similar and different. We're mostly done with that. We want to use units 1 and 2 graphic organizer to write arithmetic linear equations, geometric exponential equations for both functions and for works with means. That's what the homework was just on. And the exponent rules. We need to know those
Why didn't we get to read it?
because we're already behind
Was that
by a lot.
homework?
What?
That part?
No, we're going over it right now. So really quickly, let's start here. Negative exponents and the 0th exponent. What is a to the 0?
Hey,
Y'all, instead of writing all these down, why don't you focus on the one we're on, just write those 2 things, and then we can get going. A to the 0, what is it equal to?
0.
1, 0.
So I hear 1, I hear 0, it sounds like we're not fully sure.
I wanna say
Let's remember this. A to the 3rd, what is that? Where does that come from, I guess? Let's do it differently.
8 times 3.
2 to the 3rd, let's do that.
2 times 2 times 2.
Okay? It is kind of 2 times 2 times 2.
So,
Better understanding your definition is understanding that we start where?
Times 2. 1.
1, okay, there's McKay that said that. We're starting at a 1 and we're multiplying by 3 2s. So what is 2 to the 2nd?
4.
How are you getting that though?
2 times 2.
1 times 2.
This is also what I would put under my justification here. 2 to the 1st.
Oh, shoot.
That's 2.
Yeah, where's that coming from though?
1 times 2.
There we go, 1 times 2. So what is 2 to the 0?
0. 1.
what are we always starting with?
1.
We're starting with a 1, but how many 2's are we multiplying by?
0.
So we just don't have anything else. It's not that we're multiplying by 0, we're multiplying by 0 2's. There's no 2's there.
So that's the same for A, so it'd just be 1.
Correct.
Okay.
Not when it's a to the 0. So what about 2 to the negative 1? We'll catch up faster.
2 to the negative. Is that possible with that?
You turn the lights on, you just,
So-
I can actually see.
So is it possible with letters as well to make them negative?
Say that one more time.
Is it possible to make the A a negative?
I can't
Because
see
I
my
see that
paper.
N's a negative, but.
Well, so notice though, 2 to the second was 1 times 2 times 2. 2 to the first was 1 times 2. 2 to the 0 is just 1.
So it has to be the exponent that's negative to make it negative. No.
Well, no. A positive exponent is repeated multiplication.
Oh,
A negative exponent would be its inverse. What is the
Division.
inverse? There you go. It's division. So 2 to the negative 1 would be 1, but then what?
divided by 2.
Divided by just 1, 2. So what would 2 to the negative 2 be?
1 with, 2 divided by 2? I'm not sure.
Well, we're going to divide by how many 2's?
2.
So just
2 times 2. Okay.
so notice that's the same as just 1 divided by 2 squared.
Okay. So we don't have to write it as square, we can write it as 2 times 2.
Right, but
Square.
if we're going to do it with a to the negative n,
Okay.
what does a negative exponent indicate? Division. So it's just going to be 1 divided by,
Yeah. Okay.
a
Times A. No?
yeah,
Oh.
not times n.
N as an exponent.
N is an exponent, right? 2 to the negative 2 is 1 divided by 2 squared. Sometimes you'll hear that a negative exponent is the reciprocal, and that is true, but it's also this understanding of dividing, right? So it's both of those ideas. But you can actually write this down as justification or a little bit of explanation. We all good with that?
Yes, sir.
Sure.
Do we have those notes down?
I'm trying to
I can't
finish
see
the
my
last
paper.
3 on the blue part of the board.
I have every single.
This right here?
Yes, sir. I thought you were like just gonna just do that, and I was like, oh
How
no.
many notes on
Thank you.
But it goes underneath here. I was trying to put it in order.
Yeah, that's
Okay.
fine.
So that's kind of what I would put for my justification. It's a very quick way to explain how this is happening. It doesn't prove it for everything, but it's a good way to show it. So we actually just kind of talked about this rational exponent, a raised to the n divided by m, which if you can't clearly tell, this is what it really is. Where n divided by m is an actual exponent. I've already shown you what is that equivalent to.
We just, that,
Uh,
A
square
would.
root.
Well, it's also right here. Not a square root. Say again.
Why is equivalent 3 lines?
To differentiate from equal to. Legitimately. To show that it's slightly different.
She's laughing, she don't even know what equivalent is.
Hey, there's no need to be rude.
That's not.
Is that
There's no need to be
equivalent
rude.
to
There's no need.
with A and N? I don't know what the thing is.
It'd be equivalent to the, it would say that m root of a to the n.
Root. Okay.
So we would, yeah, we'd say m
M root.
root of a raised to the n. Okay? We're gonna talk more about this over the next couple weeks, but essentially what it comes from is the denominator indicates the what?
Which one's the, I can't say.
The denominator is what is in the bottom of the fraction.
M.
Okay? So the denominator is the what of that radical.
The root.
Say it louder.
The root.
Okay. So the denominator of a rational exponent is the root, you can also call it the index, of a radical.
I just made the weirdest T.
That happens.
But it makes me think the word.
I'm about to have to turn these lights on because it is too dark in here for us
Yes,
to
it is
clearly
very
see.
dark.
Hey.
Usually the
And it
projector's
apparently
brighter.
is putting Zay to sleep.
No, he's already there.
Nah.
So
So,
you gotta keep going,
the
bud.
denominator of a rational exponent is the root of a radical. Notice the numerator is the what? The numerator is still the,
Denominator.
that looks like a denominator to you.
N.
What is that for the base A?
Exponent.
Thank you. The numerator is the exponent, or the power. There's your justification.
Is
Okay?
this recorded?
Mhm.
Is this recorded?
Mhm.
Does that
I was
say
just making sure.
numerator or numerator?
I hope it is.
Able to say that word. It's numerator, right?
The
Is
denominator of a rational exponent is the
Huh?
root of a radical. The numerator is the
Okay,
exponent.
thank you. Because I
You?
couldn't pronounce that word with my own tongue.
I hope we all have these notes down. I see a couple people actively
who looks
writing.
I was
Okay.
writing on mine, you were writing on.
Cool.
Cool.
So multiplying numbers with the same base, a to the m times a to the n is equal to what?
Would that be like the A with the N over M, possibly? Or
No.
no, it'll be something different.
Notice there is no fraction here.
Okay, so it's not gonna be a fractional type.
There's no roots.
I'm gonna go ahead and finish writing this down real quickly.
Does anyone know what x squared times x cubed would be?
We went over that in algebra class in middle school.
We also went over it this year in this class. That'd be equal to x to the fifth.
Oh.
Oh, Sean, I had to think about that.
Yeah.
I forgot, listen, I forgot before we left for break, you teaching us that, how you supposed to add them sometimes.
Do I need to break up this group tomorrow? Can y'all be responsible?
I was listening.
Not everyone in your group was. You need to show me better tomorrow before I break those groups up. Or I will break those groups up. So notice what you say here, we were doing what, those exponents? You multiplied 2 times 3?
No, but
So what do you do with the exponents?
I know that, but you add.
Okay, that's what I was asking though.
Can we, where it says x to the second, x to the third equals x to the fifth, can we use that as justification?
No,